I'm glad you came back. All right, number 5. Let's simplify this expression using trigonometric identities. So for this one, I think we can get away with just using the reciprocal identities, right? Basically the definition of cotangent and cosecant. So cotangent is the reciprocal of tangent. So that would be cosine theta over sine theta. And cosecant is the reciprocal of sine. So 1 over sine theta. And then if you remember, dividing is the same as multiplying by the reciprocal. So cosine of theta over sine theta divided by 1 over sine theta is the same as cosine theta over sine theta times the reciprocal of 1 over sine theta, which is sine theta over 1. And then you can see that the sine thetas will cancel out, and you get cosine theta over 1, which is cosine theta. Ooh, how about this? A problem like this requires you to really kind of study that trig identities sheet and try to find something that's going to help you. Here we got cosine of x plus pi over 2, and here are some identities that might help us out. You could try this one. This one looks sort of like that one. But what I'm going to use this one. And I'm going to think of this right here, x plus pi over 2, as my theta. So I'm going to change this into sine of pi over 2 minus that. So this equals sine of pi over 2 minus theta. Right? Because cosine theta is equal to pi over 2 minus theta. So cosine of this theta is equal to pi over 2 minus this theta, which is x plus pi over 2. Alright, so I'm going to simplify inside the sine function a little bit. Pi over 2 minus, I'm going to distribute the negative sign, so minus x minus pi over 2. And then right here we got pi over 2 minus pi over 2. Well, that's 0. So this equals sine of, see, the pi over 2 minus pi over 2 cancel out, so I just have negative x. And then, if you look at this identity, sine of negative theta is equal to negative sine theta. So this is negative sine of x. Hey, I did a weird thing there. Ooh, given that cosine of 7 pi over 4 is radical 2 over 2, find the exact value of cosine 7 pi over 8. So 7 pi over 4, if you were to divide that by 2, you would get 7 pi over 8. So we want to use a half angle formula. So here is the half angle formula for cosine. Cosine of some angle divided by 2. So what's our sum angle going to be? This is going to be our A, right? So A is going to be 7 pi over 4 that we plug in right here. So 7 pi over 4 divided by 2 is 7 pi over 8. And the sine of cosine, well, let's plug in then. What do we get? We get, so we're going to get cosine of A over 2. Well, that's, so this right here is A over 2. So cosine of 7 pi over 8 equals plus or minus the square root of 1 plus cosine of A. Well, cosine of A is cosine of 7 pi over 4, which they tell us is square root of 2 over 2. And this is all over 2. And I want to make sure that my radical comes all the way down, so it doesn't look like I'm only doing the square root of the top here. There, that's better. And then this part right here says the signs of, the plus or minus, depend on the quadrant in which the angle A over 2 lies. So let's take a look at, see, I did a weird thing again. Let's take a look at where does A over 2 lie. So that's 7 pi over 8. Well, 8 pi over 8 would be pi. So right here here's 8 pi over 8. Pi over 2 would be 4 pi over 8. So, and 3 pi over 4, that's 6 pi over 8. So 7 pi over 8 is going to be right in between those guys. So 7 pi over 8 is right here. What quadrant are we in? We're in quadrant 2. And we are doing the cosine, right? And so cosine in quadrant 2 is to the left, so that's negative. So we're going to have negative square root of 1 plus radical 2 over 2 over 2. Use a product sum formula. Okay, so what's a product sum formula? Here's our product sum formulas. Which one should we use? Well, this format matches up better with the right side of these equations. Let's see. We've got a sine of something plus sine of something. So that seems to match up with this third one here. It's sine of a plus b plus sine of a minus b, and that matches up perfectly. Sine of something plus the thing plus sine of something minus that thing. So we're going to use this formula. But, look, I got a 1/2 in front, so what am I going to do? I'm just going to multiply both sides by 2 real quick. 2 times 1/2 is 1. The 2's cancel out. So I get sine of a plus b plus sine of a minus b equals 2 times sine of a times cosine of b. So this right here is, I just took this identity and multiplied both sides by 2. Why would I do such a thing? Well, because this is sine of a plus b plus sine of a minus b, where a is going to be x and b is pi over 3. So that is going to equal 2 times sine of a times cosine of b. So this is 2 times sine of a, which is our x, times cosine of b, which is pi over 3. Alright, well, what's cosine of pi over 3? Let's see, pi over 3 is right here, 60 degrees, and cosine of pi over 3 is 1/2. So this is 2 times sine of x times 1/2. 2 times 1/2 is 1, so this is just sine of x. So number 9 is talking about shooting a projectile a horizontal distance of h. And they give us our formula here. And so the picture would look kind of like this. You're shooting at your initial velocity at this initial angle, and it's going to go up in the air, and it's going to fall down, and it's going to hit your target. And this is your h, is your horizontal distance from the place where you shoot to the place where you hit. So they give us the initial velocity, that's V sub 0, or V sub, 0, means when time is 0, is 120. You need to hit a target that's 240 feet away, so H is 240 feet. So let's plug in. So H is 240. 240 equals the initial velocity squared, so 120 squared. Just want to change colors so I didn't run into this. Over 16 times sine theta cosine theta. Okay, well I can simplify a little bit here. 120 squared is going to be, let's see, 12 squared is 144, and then we'll have a couple more zeros after it. Over 16 sine theta cosine theta, and then if we multiply both sides by the reciprocal of this, 16 over 14,400, these will cancel, and we will get sine theta times cosine theta is equal to 16 times 240 divided by 14,400, which is, I get a big repeating decimal, so I'm going to simplify it as a fraction. So 16 times 240 is 3840 over 14,400. And this reduces to 4/15. Now what do we do, right? I don't have a button that's inverse sine cosine theta. So I need to figure out how to get these two to turn into just one trig function. Well, here is a bunch of identities that have sine times cosine. Oh, actually, this one doesn't really work because it should be sine A, cosine A, cosine A, sine A. So I guess if you turned all these into A's, you could probably use those. But that looks complicated. Here we got, let's see, here's some more sine times cosine. If we put these to, which one look? This one looks right here. This one looks kind of cute. It's got a sine A, cosine A, and then the rest of it is pretty simple. All right, so I'm going to take this and put it up here. And then what do we have? Let's see. Well, first, so this is where we left off. So let's make it look like that. Let's divide both sides by 2. So then I get sine, and I'll just change the A's to thetas. It doesn't matter what letter you pick. So, and I'm going to switch sides here. So sine theta cosine theta equals sine of 2 theta divided by 2. Well, sine of 2 theta divided by 2 then equals 4/15, because sine theta cosine theta is equal to that and that. So that means that sine of 2 theta over 2 is equal to 4/15. Now I can multiply both sides by 2. And my video is going to run out of time in about 30 seconds. So if you want to see the rest of this problem, you're going to have to tune back in for episode 3. Bye-bye.